of negative, or sine inverse of negative 1/2, because this is what people are going to do. They're going to have the right thought process. They're going to be like, okay, inverse says find value, then angle. And then you'd be like, oh, sine inverse only exists in quadrants 1 and 2. That is just for sine inverse. Regular sine, everything exists. All right, so we're looking at 1 and 4. We're looking for where sine equals a negative 1/2. We go negative 1/2, and then we go on the board, and we're like, oh, that's an answer up there. You pick C, and you would have gotten it wrong if you picked C.
Yeah, sure. Not pick C.
Yes, I did.
If you'd say that's 11 pi over 6, that is incorrect. It's in the right location for the unit circle, but that implies that you can go all the way around the unit circle, which you cannot do that. Instead, you have to go down. You have to go down. So instead of 11 pi over 6, you should think of that as being negative pi over 6. Instead of 7 pi over 4, you should think of that as being negative pi over 4. Instead of 5 pi over 3, you should think of that as being negative pi over 3. So instead of 11 pi over 6, to get this one right, you had to pick A, which was negative pi over 6. Arc cosine of 1/2. Arc cosine of 1/2. Instead of going to quadrants 1 and 4, cosine exists in quadrants 1 and 2. So that means this is gone. We look for where it equals just 1/2. Well, the good thing is that was quadrant 1 anyway, so I didn't have to know we're in quadrant 1. Cosine equals 1/2 at pi over 3. So our correct answer is going to be pi over 3. Okay.
For the quiz of the test,
Shh, guys.
do you want us to put like pi over 3 or 60 degrees, or do you just want us to...
Look at the directions. More than likely, you're going to put your answers in radians. Okay, so when in doubt, put radians down if it doesn't say anything specific. If the directions say you have to put it in both radians and degrees, that's where you have to list both. So be careful with be careful with the directions.
I thought you were saying be careful with the ears.
No. I was saying two things at once. Like, if the directions say draw a giraffe, you should probably draw a giraffe, because then you get a bonus point.
What?
Can you put that?
Are you going to put that in the quiz?
I put that on the test.
You did it?
That was the very first thing the test said to do.
Yeah.
What?
It's if you read the directions to the test, it says draw a giraffe.
What test?
The one you just took.
The one we just took?
Yeah. All right. What questions do we have from the homework? Before we have questions on the homework, let's go over an easy point that you guys all could have gotten. And that is number 22. Number 22 says sine of alpha equals negative square root of 3 over 2. If you put 5 pi over 6, that means you were just copying the answer key. That is so far wrong. There's nothing right about that. So if you look at yours and it says 5 pi over 6, that means you're copying the answer key. Which, ask yourself, what's the point?
It can't be negative if it's sine.
It can't be 5 pi over 6 to begin with. Pi over 6 doesn't make any sense. Yep. Not even the right quadrant. 5 pi over 6 is in quadrant 2. Doesn't exist there. So if I was doing sine alpha equals negative square root of 3 over 2, we'd take the sine inverse of both sides. Let's get in the habit of being able to write that. Sine inverse of this side, sine inverse of that side, which this question is actually asking alpha equals the sine inverse of negative square root of 3 over 2. We go back to our unit circle, negative square root of 3 over 2. We can't be in quadrant 2 or 4, or 3. We have to be in 1 or 4. Well, we look down at 5 pi over 3 and go, oh, that's where it equals negative square root of 3 over 2. But we realize 5 pi over 3 is not our answer. It has to be negative pi over 3. The correct answer for that one should have been negative pi over 3. I did see people erase theirs. Remember, don't trust my answer key. If you think something's wrong, you email me and you get a bonus point if there's a mistake on the answer key. Let's look right above that. So that was number 22. Let's look at 19. 19 wasn't finished. Hey, if I don't have a finished problem, you better finish it, because I'm more than less likely going to check that one for your homework that you actually did something. You can't just stop. If you just stopped on 19 because my answer key stopped there, in the future, that's just going to be you didn't check your answers or you didn't fully give me your effort, because it was the exact same thing as the 2 before it. So 19 stopped at the point that alpha equaled cosine inverse of negative square root of 3 over 2. If you fully did this, you should have came up with, 5 pi over 6 would have been the correct answer. Be careful with the answer keys, because as we go on further, we're going to have more things missing. We're going to have things wrong that I try to make obviously wrong. And it's going to be a good sign that you're just copying the answer key. And if I start thinking you're just copying answer keys, you're not getting points for the homework. Better off just saying it's not done. I'll get it done tonight, and I'll email it to you and learn this stuff. Because as soon as you're copying the answer key, there's no getting those points back. If I think you're copying the answer key, that's 0 points. There's no way getting it back. You give me something that's not done. Several people just said I didn't get around to doing it. Okay, get done. Email me it and know that information. All right, what other questions do we have from the homework? Sure. What's 28 say? 28 says secant of 17 pi over 6. What I'm looking at, 17 pi over 6 is not on my unit circle. But pi over 6 is. So that must mean it's just too big of an angle right now. So let's knock it down a little bit by subtracting 2 pi from it. So minus 2 pi. Well, 2 pi doesn't really help me. I know it has to be over 6. So I'll make it 12 pi over 6. That makes that 5 pi over 6. Now remember what we're doing. This is the same thing as secant of 5 pi over 6. We're actually looking for where is cosine? 5 pi over 6. And we get that value and we just flip it. So if I go back to my thing, cosine of 5 pi over 6 is going to be negative square root of 3 over 2. We'd flip that and we'd have negative 2 over square root of 3, but we would need to simplify that. So we would have, do you get the negative 2 over square root of 3 where I got that from?
Not really.
Okay, let's highlight the stuff. So I'm looking at 5 pi, I'm looking at, we're just doing regular secant, yeah. So we're looking at 5 pi over 6. Secant says look at cosine. 5 pi over 6 leads us to this. That's cosine. If you flip it, it becomes secant. So negative 2 over square root of 3 is secant. Just like if I'd flip 1/2 and turn it to 2 over 1, this would be cosecant. So it saves us from having to write those values down every single time. Yeah?
Say for this one, you put negative secant of 17 pi over 6. Would it end up being square root of 3 over 2, or would it be...
Say that one more time.
So you did negative secant. Would it end up being...
So if I put a negative sign in front of this,
Yeah, would it just be square root of 3 over 2, or negative...
it would make it positive, yes.
Or, but would it be 3 over... Or negative 3 over...
Nope.
2 over...
Nope. What would happen if let me finish this and we'll go back to that question, okay? I just want to finish this. So this problem isn't done because it has a square root of 3 in the denominator. Are you now okay with where I got this from? Okay. Now to simplify this, we would multiply the top and bottom by square root of 3. That will give me negative 2 square root of 3 over 3. And then the question is, what if it started off as a negative sign? Lewis, can you pick up your head, please? Thank you. If it had a negative sign in front of it, like you're talking like this, right?
Yeah, so it'd just be...
That negative, would just travel along with it. Think about it being in parentheses.
But you still could have a negative in the denominator.
Well, so we'd have a negative times a negative, which would make it positive.
I thought negative secant flips it to cosine, or...
Oh, you're talking about inverse.
Inverse. Like,
Oh, inverse.
Inverse of secant, sorry.
Yes, we're doing that today. Let's do that today, okay?
Sorry,
Now, the big thing about this and why I can't replicate that problem is because you can't take the secant inverse of an angle. You have to take the secant inverse of a value. So I'd have to change a lot. I would have to change this to...
You didn't take an angle,
I would have to put that in there.
though. So it has to be like pi over... Oh, yeah.
It has to be a value. It can't be an angle with
So,
pi or
like,
degrees.
We're solving for the value.
Yes. So I could do the secant inverse of negative 2 square root of 3 over 3, and that would pump out
So that
5
was
pi
the
over
example we
6.
did yesterday with the A.
Yeah, but we're going to do that with secant and cosecant today. That's all we're adding today is cosecant and secant. So you led us to the next problem. Other questions from the homework, though, before we dive in? Okay. So we have a fresh unit circle. We have a problem. Hey, guys, skip these smoke and mirrors for just a second. We're going to go down to the graphs like we did with sine and cosine. So we graphed sine and cosine the other day, and we said they didn't pass the horizontal line test, so we had to restrict the domain. We're going to do the same thing for secant and cosecant. So we're going to talk about cosecant inverse first. So cosecant, when you think cosecant, you have to think sine. You just have to. Cosecant and sine, they're boys. They hang out together. They do a lot together. They're just kind of reciprocals of each other. Okay, so if I ask you to do a cosecant graph, you should first do a sine graph. A lot of us forgot that. And a lot of us just try to go right to the answer, and we got a lot of those wrong on the quiz. So let's just stick with, if I ask for a cosecant graph, the first thing you do is a sine graph. That's what I'm going to do first. Once I screw the tip of my pencil back in so it can actually do stuff. Cool. All right, so I'm going to do it in a very light color because I know it's not the answer. Sine starts at 0, 0. It goes up 1, so I guess I should probably have a 1 on there. Goes back to the sinusoidal axis. Goes down to -1, and goes back to the sinusoidal axis. Now, I'm going to go ahead and I'm going to very lightly finish this graph, knowing that's not my final graph. What's something I need to do to turn that sine into a cosecant? There's two things I need to do. What was that? I need those vertical asymptotes. So Drew said, draw your vertical asymptotes. And as a reminder, your vertical asymptotes are wherever it hits the sinusoidal axis. For right now, it looks like it's at 0, so I'm going to draw it here. It's basically those middle points. Vertical asymptote here, and a vertical asymptote here. So I'm a vertical asymptotes. What's the next thing I need to do to complete?
Make sure it doesn't cross the asymptotes.
Make sure it doesn't, but what are we going to do with the bumps? Flip the bumps. Flip the bumps and make sure it doesn't cross those vertical asymptotes. I did see that on the test or the quiz. Make sure you don't accidentally do this because then you just got rid of those asymptotes. Make sure you at least try to keep them within those bounds. So that's my flip bump. That's my flipped bump. And that right there is a basic cosecant graph. Now, we have to restrict the domain to actually have something that passes the horizontal and vertical line test. Well, even if I restrict the domain here, this little u does not pass the vertical line test. The horizontal line test. Nor does this one. Now, what they did, and it actually makes your life easier, is they replicated what they did for sine. If you remember the other day for sine, we actually went backwards. They actually said, if I just go backwards a little bit, and I'm going to flip this part of the bump to make it kind of look like this. And then if I just box something in orange, restrict the domain from -π/2 all the way to π/2, and I say everything else is gone. What's inside that orange box passes both the vertical and the horizontal line test. But just like with sine and cosine, that's going to restrict our unit circle axis. We can't access the entire unit circle because our unit circle goes from 0 to 2 pi. Well, I relegated it to -π/2 to 2. If you turn your page back to your notes on sine inverse, you're going to see that's the exact place we restricted sine to. So this is going to be the exact same quadrants. It's going to be quadrants 1 and 4. So when I talk about cosecant inverse, we get rid of quadrants 2 and 3, and we just are in quadrants 1 and 4. Now, just like the bell work pointed us, if we get down to Sure. So we have to restrict our domain so it can pass the horizontal line test. So some mathematician said, okay, stop looking at the whole thing and only look at values where I input -π/2 to π/2. Well, on our unit circle, -π/2 would be straight down. And they said you can go all the way up to π/2, which is straight up, but you can't go anywhere else. So everything else here is gone. I can't do it because that's what breaks it being a function. So it's a little confusing, but you just have to trust me that some mathematicians said we have to cut it up like this so we can make it a function. Okay, so we have cosecant exists in quadrants 1 and 4. When we get to quadrant 4, just like with sine inverse, you have to no longer think about 11 pi over 6. You have to think about negative pi over 6. Instead of going 7 pi over 4, you need to think about that as being negative pi over 4. Instead of 5 pi over 3, you have to think about negative pi over 3. And I already mentioned the negative pi over 2. So if I ever talk about down that fourth quadrant for cosecant inverse or sine inverse, just for inverses, we're only in inverse world right now, you have to use negative angles. Next thing I'm about to do, don't worry about it on the test. I'm going to graph the inverse, just so we can see it. We're not in an inverse section, so I won't put this on the test. But just as a reminder, we will have an inverse section probably next semester or something. For inverses, all you do is swap your inputs and outputs. That means find a couple points, flip your x and y values, and you have your graph. There is a nice shortcut to something like this. So what I'm going to note here is, if you look here, I have a vertical asymptote at 0. If you switch your inputs and outputs, a vertical becomes a horizontal asymptote. So this actually has a horizontal asymptote along the x-axis. So I'm going to go ahead and do my horizontal asymptote.
Why wouldn't it look exactly like the sine graph?
It will in sorts. I don't want to get into that, but you can see it is a reciprocal of the sine one. It is the bumps are flipped. But let me finish this real quick, and maybe you can look back at it. So the 2 points I'm just going to pick are, if you look at this negative pi over 2, negative 1 point, and the only other point I'm going to graph is going to be this pi over 2, 1 point. Our job is to flip those two things. So instead of negative pi over 2, negative 1, I'm going to plot negative 1, negative pi over 2, which would go right here. The other point, I'm going to flip pi over 2 and 1 to be 1 pi over 2. Now, I did the vertical or the horizontal asymptote first because we don't have to plot any more points. We just know that this is attracted to those particular points. So I think it was Dylan, you talked about the sine graph. If you draw your sine graph over this inverse, it would look like the bumps are flipped. So don't do this. You don't need to know this, but it is a great question, so I'll draw it over this. That very light one would be our sine inverse graph, which if you look at, we flip the bumps the other direction.
So we just can't have values between negative pi over 2 and pi over 2.
Yep. But it's taken care of. It's taken care of for us. You don't have to worry about the graph. Focusing on the graph is going to make your life a little harder. Just focus on the unit circle. All right. Once again, don't worry about the graph. Worry about this right here that we're in quadrants 1 and 4. Okay, now let's bring up this thing that I'm talking about up there. In fact, let's go back to the unit circle really quick. Let's just hash some things out real quick. So on one of the first days of your pre-calc class, way back in the wee days of August, I said if I asked for the sine of pi over 6, you would find pi over 6 and say my answer is 1/2. So remember that logic. So if I ask for the sine of pi over 6, you have to give me out a value. I give you an angle, you kick me out a value. Then we upped the ante and we said, what about cosecant? Well, I said cosecant are best friends with sine. So if I asked for the cosecant of pi over 2, you said, or pi over 6, you'd find pi over 6. Sine is 1/2, so that means cosecant would be 2 over 1. So in fact, if you had plenty of time on the test, you could just flip all of these. I just want you to picture this. I could flip all of these. This would give me the secant, cosecant, and cotangent values. Definitely don't have to do that. It takes too long to do that whole thing. So follow my logic here. So if I ask for the sine of pi over 6, you go to the value. If I ask for the cosecant of pi over 6, you flip the value. Now, the last time I saw you, I switched it up and I said, what about inverses? I said, what if I give you sine inverse of 1/2? If I give you sine inverse of 1/2, I give you a value, you give me an angle. Sine inverse of 1/2 equals pi over 6. I can't ask for the cosine inverse of 1/2. Instead, I have to ask for the cosecant inverse of 2/1, which would give me pi over 6. Because we said sine of pi over 6, 1/2. Cosecant of pi over 6, 2/1. So to go backwards, I have to give you the sine inverse of, can you guys pay attention to this? This is pretty important. This is like the key to this. If I ask for the sine inverse of 1/2, if I want to use cosecant, I have to use the cosecant inverse of 2/1 to get back to this angle. So notice I took the reciprocal of the value again. So that led me to this statement here. Sine of pi over 6 equals 1/2. Cosecant of pi over 6 equals 2/1. If I asked you for the cosecant of -1, you have to go, cosecant's not on my unit circle, Mr. Pabian. There are no just 2's on my unit circle. You need to convert cosecant inverse to sine inverse by doing the reciprocal of the value. You did the reciprocal of the value here, it's just this time it happens within the parentheses. So I'm going to have a saying that I'm going to use consistently for you. I'm going to continuously say inverse reciprocal inside. Inverse reciprocal inside. The only time you have to worry about this is if it's not on the unit circle. That means cosecant, secant, and cotangent. So your first question is going to be from now on, is it on the unit circle? If it's not, you have to do a reciprocal. Either it's going to be the reciprocal inside if it's an inverse, or you're going to do it on the value, I call it kind of outside. It is you find the value and then you do the reciprocal. Yeah?
What if it's inside but it's not inverse? Like just
Then we don't care.
like cosecant of pi over 6.
Yep.
There, so
We just flip the value. So we find the value of sine and then we flip it. So Dylan, to answer your question, there's another way algebraically to do this, and we've shown this, that cosecant of pi over 6 is really 1/2 sine of pi over 6, which means it's 1/1/2, so you're doing the reciprocal outside. I call that doing the reciprocal outside because you first have to find your value and then do your reciprocal. You have to do your reciprocal first to even get back to your angle.
but is it not already isolated when you have cosecant? Oh, because we changed it to sine.
Yep, because we have to change it to sine. So two bits of advice. It's not in the unit circle. If it's inverse, you do the reciprocal inside. Here's the second bit of advice. You will never, ever, 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 ever take the reciprocal of an angle. That means you'll never, ever flip a fraction that has an angle. You'll never say this is 6/pi. You are always going to take the reciprocal of the value. So if you know you have to take a reciprocal and you forgot where to take the reciprocal, it is always the value. So here I'm looking at 2 is the value, it's not an angle. So I need to take the reciprocal of that. When I look here, I'm like pi over 6, nope, that's an angle, can't take the reciprocal, I must have to take it after I find the value. If that sounds confusing, here's the thing, it just takes practice. Practice and questions, yes? Should we run through some examples and then we'll...
For like sine, inverse of sine, what if that's not a fraction, like on the unit circle? Like what if it's not a factor? What if you just
It's going to be on the unit circle.
okay.
So one of the signs that you did something wrong is it's not on the unit circle. So if I took the reciprocal of pi over 6 and I have 6/pi, we don't have 6/pi on our unit circle. That means I did something wrong. 2 is not on our unit circle, so that means I have to do something to it to put it on the unit circle. Oh, there's plenty of 1/2s on there.
I'm saying like instead of, what if cosecant was 1/2 and sine was 2? Would that just be
I would not ask that question. So if you said, what's the cosecant inverse of 1/2? That means I'm looking for the sine inverse of 2, which is not on our unit circle. Not going to ask that question. In fact, that doesn't exist. Okay. Keep that in the back of your mind. Let's do some problems with this. Okay. So cosecant of -1. My first question I ask, is cosecant on your unit circle? No, you just have sine, cosine, and tangent. So it's not on the unit circle. That means you have to use a reciprocal, whether it's going to be inside or outside. So we have an inverse. So that tells me it's an inverse. That means reciprocal inside. So I need to rewrite this in terms of sine. So I'm going to rewrite this as sine inverse of, now remember it's square root of 2 over 1, so if I flip that it becomes 1 over square root of 2. Yes. So is 1 over square root of 2 on our unit circle? I'll accept both answers. It is and it isn't, because it's not written in the form 1 over square root of 2. It is going to be, we have to multiply the top and bottom by square root of 2 over 2. The quicker you start realizing what this actually is, because what's the only thing on the unit circle with sine that has square roots in it? We're looking at pi over 4s and stuff. I'm looking for square root of 2 over 2. So for those of you that aren't following along with what I'm saying 1 over square root of 2 is not simplified. To simplify it, you multiply the top and bottom by square root of 2 to get out square root of 2 over 2. Square root of 2 over 2 is on our unit circle. So that's easy enough to go, oh, sine inverse of 1 over square root of 2 is the same thing as sine inverse of square root of 2 over 2, which should equal pi over 4. But a lot of us already said pi over 4.
You don't finish after you flip it. You have to get rid of the square root.
You do, because that's how we wrote our unit circle. If you want to go back and change all your square root of 2s over 2s to be 1 over square root of 2s also, because they're equal to each other, you can. But I would just go ahead and, if you see a square root in the denominator, just simplify it and see if it helps you.
But then won't that give you square root of 2 over 4?
It would give you square root of 2 over 2. So, yep. Which is on our unit circle, right?
Oh, yeah.
Yep. And that happens at pi over 4. All right, the next one is arc cosecant. I don't like arc cosecant. It confuses people. I would like you just to go, well, that's actually cosecant inverse. Same thing. Just a different way of writing it. So same thing. All right, is cosecant on your unit circle? I'm going to ask that every single time because you should ask that. No, it's not, which means you need to do a reciprocal. Either that reciprocal happens outside or inside. This is an inverse, so it happens inside. Can someone tell me how I'd rewrite this in terms of sine inverse? 1 over 2 is correct. Remember, these are equal to each other. They're not to help, they're equal to each other.
So you always do sine no matter what? If it wasn't just...
Well, if we do we're going to do secant inverse in a second.
Okay.
Yeah. Make sure you have here what quadrant stuff.
Can you wait? So arc cosecant is
Yep.
just sine inverse.
It's just cosecant inverse.
Why are we doing equals sine inverse?
Because cosecant's not on our unit circle.
Oh, okay.
So rather than having to write all of our cosecant values on, I'm just going to relate it to sine.
Okay.
Remember, all they're saying is if I just do a reciprocal, you can get between sine and cosecant. Okay? All right, so we now have sine inverse of 1/2, not 2 anymore. I bet you sine equals 1/2 at pi over 6. That should be one we should start getting comfortable with because sine, you follow the sine goes 1, 2, 3. The quicker you start learning that, the quicker you don't have to look at your unit circle every 50 seconds. 50 seconds, that's a weird. Yeah. 15 milliseconds, yeah. Yeah, all right. Next one, cosecant of 3 pi over 6. Is cosecant on your unit circle?
No.
Does that mean I'm going to flip this fraction to be 6 over 3 pi? No. You never, ever, 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 ever flip an angle. I should simplify it, though. I should go, oh, that's actually asking for the cosecant of pi over 2. Now, we have two ways to look at this. Either go to unit circle, find sine of pi over 2, and flip the fraction. Or you can rewrite this as being 1 over sine of pi over 2. Do not just copy down what I write. Think about what makes sense to you. Do you prefer to just find on the unit circle and flip it, or do you prefer to write the algebraic statement? These are two different ways to tackle the same problem. I don't care which method you choose. Typically, I would just find it and flip it. It just makes more sense to me, but it's not for everyone. Okay, so sine of pi over 2, that's straight up right here, right? So that must mean it's 0 or it's 1. Which one is that? It's 1. So we're going to take the reciprocal of 1, which is 1 over 1. You flip it, it turns to 1 over 1, so it's 1. It's hard to write that, but it is still 1. It's basically I flipped that fraction 1 over 1 and became 1 over 1. Algebra-wise, it would look like this. I'd actually have 1 over 1. And then you flip it again. Do what you do. All right. Now the next one says cosecant inverse of 1. Cosecant, is that on my unit circle? Is cosecant on my unit circle? No. That means I need to do an inverse. Are we going to do the inverse inside? Yeah, because we're going to do the reciprocal inside because it's an inverse. What's the reciprocal of 1? 1. So cosecant inverse of 1 is the exact same thing as sine inverse of 1, which just happens to be pi over 2. I just went backwards. Guys, someone in the last class had a great question. On the test, will I partition it between inverses and non-inverses? I will not. But here is a good tactic for tackling tests. Can you divide them up in your head? Yeah. Just do all the ones that aren't inverses first, and then go back and do all the inverses once so you can follow the inverse rules. That way you're not constantly switching your brain back and forth. That's what I would do. I would tackle all the ones that aren't inverses. Otherwise, you get confused going back and forth sometimes. All right, so that is cosecant. Question on cosecant inverse. If you understood cosecant inverse, secant inverse is the same thing, except now we're looking at cosine values. All right, we do have to tackle the graphs real quick, so let's do that quickly. If I'm doing a secant graph, the first thing I do would be a cosine graph. Cosine starts at 0, 1, goes down the sinusoidal axis all the way down to -1, and goes back up. Is that too light for back there?
No.
Oh, okay. Totally cool. Yeah, people in you can move to that table too if you really needed to. Guessing it's Holden's head that's in the way.
Such a big head.
Nothing about it. He's just right in front of him. That's just basic geometry. All right. Is this the graph of secant? No, you have to put your vertical asymptotes and flip the bumps. Vertical asymptotes where it hits the sinusoidal axis. That's the sound of vertical asymptotes, by the way. Flip your bumps. And that is definitely my secant graph. Very distinct. Secant does not pass the horizontal line test. I don't need to write any more of it because what they did is they said, well, if we just draw a box around this at 0 to pi, it would pass the horizontal and vertical. Remember, if this is a little confusing, don't worry about it. Just know the quadrants we're going to talk about after this. So 0 to pi, if I start at 0, I'm right here. Pi goes all the way back here and doesn't go any further than that. So we're talking quadrants 1 and 2. Does that match cosine inverse? Yeah, that's important. That's actually, we're going to find out tomorrow how important that actually turned out when we talk about cotangent and tangent, because those do not. So stand by for tomorrow.
Oh, you can also do the secant and cosecant.
There we go.
Like the SEC.
Yes, you could. I'll show you one way to do it. You could definitely do that. It's not the way I would do it, but I see what you mean.
Yeah.
Okay, guys, let's refocus. All right, so we have secant is now in quadrants 1 and 2. I do have to graph the inverse. The first thing I would do if I was graphing the inverse, I would look for any vertical asymptote and turn it into a horizontal asymptote. A vertical asymptote at pi over 2, horizontal at pi over 2. Just to speed this along, I'm looking at that point 0, 1. Flip it, it becomes 1, 0. And would go like that. The other point I'm looking at is pi -1. Pi -1, if I flip it, it turns into -1 pi. And I'd graph that up here. This is our secant inverse graph. If you don't understand that, that's okay. The big thing is quadrants 1 and 2 right now. Yeah, Drew.
So is the
We would not have a sinusoidal axis when we get to those inverses. It'd be a horizontal asymptote. Yeah. Yeah. So if I have so when we get to our inverse unit, not right now, but we'll talk about like vertical asymptotes turned horizontal asymptotes and vice versa. And that's just because our x and y values switch. So if my output is a straight line, that means my new input is a straight line, but that makes it horizontal. Okay. Let's go back to the statements up here. Day 1, we said cosine of pi over 2 equals square root of 2 over 2. Then recently we said, oh, if I find the secant of pi over 2, I find the cosine value and flip it, so that makes it 2 over square root of 2. Obviously, we'd simplify that. Now, if I'm looking for the inverse of 2 over square root of 2, that's going to match up with the cosine inverse of square root of 2 over 2. Once again, inverse, reciprocal inside. I change it to cosine square root of 2 over 2, which brings me back to pi over 4. One more time, inverse, reciprocal inside. I'm going to go through all my same questions again. Is secant on your unit circle? No. That means you have to do a reciprocal. If it's an inverse, you do the reciprocal inside. Once again, you always take the reciprocal of the value. -2 is definitely the value. And if I was on the test and I forgot what I was doing, is -2 a value that's on your unit circle?
Yes.
No. -2 is not.
I'm sorry.
But if I change it to cosine,
Now we're talking.
cosine inverse, I could change that to a -1/2, which that's a good sign that I did it right because -1/2 is on my unit circle. Now, cosine inverse and secant inverse both exist in quadrants 1 and 2. So if I want -1/2, does anyone have that?
Oh, I did it wrong.
I do.
2 pi over 3.
2 pi over 3 is
2 pi over
correct. Arc secant, remember, that's the exact same thing as secant inverse. Is secant on your unit circle?
No.
Inverse inside, reciprocal inside to change it to cosine because cosine is on my unit circle. All of a sudden I'm at 1/2. If -1/2 is 2 pi over 3, then 1/2 must be just a positive pi over 3. Okay, Enrique was already talking about this. He's just like, how do I remember this for the test? And he was like, oh, it lines up. I can do secant, cosecant, just like we did cosine, which is great. What I typically do, on the top of a test, I would still write cosine. I would still write cosine so I know what quadrants cosine and sine inverse exist in. Then I would ask myself, what's cosine's brother? It's secant. So I'd write secant above this. Now, why I do it this way is because now this is on the top of my test. I don't have to worry about it anymore. As soon as I get the secant, I can look back at that cover and just go, oh, secant and cosine. You can kind of let it go to the back of your brain. And then I'll write cosecant over here. We're actually going to do a new one for tangent and cotangent. We'll worry about that tomorrow. All right, I do want to go over something really quick. I hope this doesn't confuse you. It helps some people, it confuses other people. Yeah, we'll find out. If it doesn't make sense, you cross it out as soon as I do it. Okay, so here's my thought process. If I ask you to do cosecant of, let's just say, an angle. That's an angle. You know your answer needs to be a value, which means you need to convert this to sine and flip it. So this is going to result in 1 over sine of that same angle, which is kind of like just 1 over x. It becomes a value. We get a value out, we take the reciprocal. So this tells you, find sine, flip that fraction. That's all it says. Find sine, flip the fraction. Now, if I'm going the opposite way, if I ask you to find cosecant inverse, be careful of what you write in here because it has to be a value and not an angle. This is cosecant inverse of a value. It's not on my unit circle, so I need to take the reciprocal of the value. It's always of the value. Inverse inside. So once again, if you want to put that inverse, inverse inside. I can rewrite this as sine inverse of 1 over x, which would equal an angle. Always. Inverse will always kick out an angle. It's important for you to keep track of where angles are and where values are because it can be a good sign on whether you're taking the reciprocal and where you're taking it. If that is completely confusing, scratch it out right now and just go, ugh, I don't like it. All right, now, here's my advice, just like I said in the last advice. It's just important you practice this stuff. The more you practice this stuff, the easier it becomes. Because if it's just kind of like it's almost there, it takes you going home and practicing this over and over, and all of a sudden it can click. If you just go home and copy the answer key, nothing clicks. You don't know how to do cosecant. You don't know how to do inverses. And you're going to struggle on the test. Because you can already picture on the test, it's going to have a big box that has everything we've done reading the unit circle on. So it can have sine values, cosine values, cosecant, inverses, all of the... All right, questions. I saw Dylan might have had one. Let me pause this real quick.